Welcome back, welcome back, welcome back. I'm Miss Lisa. This is my YouTube channel for math and science. This is physics class, and we're talking about work, energy, and simple machines. And we're going to do some of the problems out of the book, if you're following along, that have to do with these topics. This is Chapter 10, Part 2. So there's some people with some simple machines, some bicycles. And we're going to do the first problem. Okay, so remember, what makes word problems hard is the words, so we got to get rid of the words and do the problem. Okay, and it says, a student, here he is, lifts a box of books that weighs 185 newtons. So remember, we get rid of the words. We don't really care it's a student. We really don't care that it's books. We just care about the numbers. So we know that it weighs 185 newtons, and that's the force that he's going to have to use to pick that up. Okay. The box is lifted 0.8 meters. So the distance is 0.8 meters. And then it says, well, how much work does the student do? So there's my knowns and unknowns. Now I think to myself, is there a formula that relates force, distance, and work? Why, yes, there is. Work equals force times distance. Now I sing the song. What's the song? Substitute. And underneath the F, I write 185. Underneath the D, I write 0.8. I multiply them on my calculator. And it is 148 Newton meters. A Newton meter is the same thing as a joule. And we put work in joules, so we say 148 joules. That one was easy, wasn't it? Remember, I always assign these to you that have the answers in the back of the book. So be sure to do them and check them. Okay, number 2. A sailor, and remember I told you that we love pulling things at an angle. So this is work at an angle. Okay. A sailor pulls a boat along a dock using a rope at an angle of 60 degrees. So that's our first thing. With the horizontal. How much work is done? So work is our question mark. By the sailor if he exerts a force of 255 newtons. Okay. On the rope to pull the boat a distance of 30 meters. Okay, so there's all my knowns and unknowns, and I think to myself, is there an equation for work at an angle that uses an angle, force, and distance? Yes, there is. Work equals the force times the cosine of theta times the distance. So let's put that in our calculator. Use your TI-84 graphing calculator, clear out what's in there so it looks nice. Okay, so our force is 255 times the cosine, and you don't actually have to say times. Your calculator knows it's times if you just do it next to it. Times cosine, and our theta is 60, close the parentheses, and our distance is 30. So your calculator knows all that means multiply. And there's the answer, 3825. 3825 joules. Aren't these fun? Don't you feel smart? You get to use the cosine button. Okay, here's our next one. Okay, so once again, this time, looks like we got a lawnmower. Let's read it. It says, an electric motor lifts an elevator. This is an elevator. That weighs 1.2 times 10 to the 4th newtons. So remember, weights are your forces. So I put that down first. Force equals 1.2 times 10 to the 4th newtons. A distance of 9 meters. So next, I write 9 meters in 15 seconds. So my time is 15 seconds. Then it says, what is the power? So power is what I don't know. I should have written power question mark. I always like to list my knowns and unknowns. Power is what? Okay. And it says, what is the power? Well, is there a power equation that relates force, distance, and time? No. But there is one that is power is work over time. So I need to get the work. Work is force times distance. So first I do 1.2 times 10 to the 4th times 9. Now, how you do this on your calculator is use that button right here that says EE. Do not do times 10 up arrow like that. The reason why is your calculator has a hard time realizing that this is one number instead of two. It thinks the 1.2 is one number and the 10 to the 4th is another number. Some problems it actually won't matter on. but I want you to get in the habit of doing it right so that you won't miss some problem in college and make a bad grade because you didn't use your EE button. All right, so let me show you how to put it in. So to get to the painted on stuff, you use the second button. So I'm going to do the force. I start by putting the 1.2. Now I do second comma, and it puts an E. That E means times 10. And now I put the exponent, and the exponent is 4. I don't do up arrow. I write it right here in what I call numerator land, not up in exponent land. Okay, so that is how you tell your calculator the number 1.2 times 10 to the 4th power. And now I need to multiply that, so I hit multiply times 9, my 9 meters, and there's my work, 108000. All right, so now I've got work, I've got time, and I can substitute them in. I'll sing substitute, and I do this, and I can just leave it on my calculator and do divided by 15, and then I don't have to rewrite it. And it says that 7,200. This is watts, so the B part of the question says, well, what about if it's kilowatts? So the way they did it is they divided by 1,000, but the way I like to do it is I like to use the beauty of metric, which is King Henry's daughter bakes delicious chocolate muffins. I'm at the basic unit of watt, B for basic. I want to go to kilowatts. I just count the frog hops. 1, 2, 3 this way. So my decimal point goes 1, 2, 3 this way. And there's the answer, 7.2 kilowatts. So that's easy. This other way is dimensional analysis. It always works, but if it's metric, it's faster to just frog hop it. All right, that's the lab you're going to do going up the stairs. Here's some simple machines. Okay, example problem 4. Now we have a bicycle, and we're going to figure out some different things about it. So let's read about it first. A student uses the bicycle wheel with a gear radius of 4. So the gear radius is 4, okay? And a wheel radius of 35.6 centimeters. Wheel radius, 35.6 centimeters. When a force of 155 newtons, is exerted on the chain, the wheel rim moves 14 centimeters. So the distance that the rim moves is 14 centimeters, okay? Due to friction, its efficiency is 95%. Okay, so those are all my knowns. Look, I got rid of all those words and got just these numbers. That's what we want to do. We want to get rid of the words and make it just nice, easy numbers. Okay, so A, what is the IMA, ideal mechanical advantage of the wheel and the gear? Well, the ideal mechanical advantage is the distance out divided by the distance in, which is the gear sub r out over the wheel sub r, the radii, divided. So my gear was 4, my wheel was 35.6. I divide them and I get 0.112. So that's my first thing. I got my IMA now, 0.112. Okay, question B. That one wasn't too bad. What is the mechanical advantage, the MA of the wheel and gear? Okay, so I can get that. I can get the mechanical advantage because I know the efficiency and I know the ideal mechanical advantage, so I can solve for it. The efficiency they told us was 95. The mechanical advantage I don't know, but I just solved for the ideal mechanical advantage is 0.112. So now I just do it on my calculator by doing the opposite until I got it by itself. So I'm going to start by putting 95 in my calculator. And now I want to get mechanical advantage by itself, so I do the opposite, and I work from the outside in. It's being multiplied by 100, so I divide both sides by 100. So 95 divided by 100 equals 0.95. These hundreds cancel out, and now I've got mechanical advantage equals 0.95 over 112. So now I want to get the 112 out of the denominator, so I multiply both sides by 112, 0.112. Those cancel out. So now I do times 0.112, and I get it's 0.064. So the mechanical advantage is 0.1064. Okay, next problem, C. We're just zipping right through these. What force does a scale attached to the wheel read? So that is the force is that F sub R. We know our effort force was 155 newtons, and we know our mechanical advantage. So we can just solve for it. We put into our calculator, but we've already got it, 0.1064, and then we multiply both sides by 155, and we get 16.492. Ta-da! And that's newtons, okay? Letter D. I almost said number D. How far did the student pull the chain? Well, we can get that one from our ideal mechanical advantage thing. We know that the dr, our radius here, was 14. We know our ideal mechanical advantage, we solved for it up here, it's 112. We put it into this formula, we multiply by 14, so it's 0.112 times 14 equals 1.568 centimeters. Ta-da! So that one's a little bit complicated, but not too bad. If you just work your way through those formulas, you'll get to practice it, you'll get good at it, and that's chapter 10. Woohoo! We are moving right through. We are almost halfway through this book. You're doing awesome. So like, share, subscribe. I have a goal. It's 1,000 subscribers, so don't just like. Hit that subscribe button for me. You can turn off notifications because I know that I'm a pain because I do lots of videos. Turn off notifications, but go ahead and subscribe for me, all right? Science is great, physics is great, and life is great. See you soon.